relatively stable anion, and so the hydrogen comes off pretty easy. Next door to this. So if you add hydroxide to this, what you can generate in the first step is this fancy nucleophile. And then this can do anything other nucleophiles can do. So in the second step, this can attack this carbon and pick this out in two steps, not a single step. So the final product you're going to get, if you to acetone, this is acetone, add hydroxide, you get this. And then if you add this ester to it, the final product you get this is substitution. There's a substitute for this. This you get this. Okay. So just generates a nucleophile in the first step, and then it does anything you learn in nucleophiles can do. It can do also.
Do we need to know the step or just be able to answer the?
Just give the final product.
Okay.
If you take a biochemistry class with Dr.Loehr, he covers these reactions, so that's why you've seen it. Okay, anybody have any questions on any relates to chapter 20? Yes.
The homework from chapter 20, just number 35, there were a couple in there that I didn't understand.
Okay, which one?
First of all, C. I don't.
Which one?
C.
C. They get Q.
What?
C is a rehash of this reaction here. Two reactions, I guess.
Excuse me.
You know what's going to
C?
happen. You have carbonic acid.
No. 20,
And you have
35.
SO2.
2035.
So you get a reaction.
Thanks.
Mhm.
Okay. And you also know you have an aromatic and you have RCO1OCO and aluminum chloride. When you mix these guys together, remember what you get. You get this. This is my E plus. This can attack the benzene ring. And you get a substitution. Okay. So those are the reactions that are taking place in this outlandish compound here. Let's see. 1, 2, 3. You kind of drew it the way you want to. Yeah. One carbon here, here, here. So this is what you got, all right, to start with. After step 1, you get this. Okay, this is top reaction. Then if you had aluminum chloride with this is my RCO, then this is gone, and you're gonna get plus charge here. G plus charge here. And we get hydrogen here. So now what happens is an internal, instead of having this on one molecule and this on the other, they have both of them together on the same molecule. And so now this substitutes for hydrogen, and you get, I imagine the product you're going to get is a ring chloride. just that this R right here and this aromatic compound are connected. They're not two separate pieces. You get your R, C, no bond, O, C, L. So it's connected, so it can react with itself, basically. They get a bit cute for them, real good there. But that's basically what it is. It's the first reaction and the second reaction. The second reaction here, you have two different materials reacting, but they can be connected, and so that's what they have in your example. They're connected, so they react with itself. I probably would be hard. That's why if you can do the homework problems, then you won't have any trouble with the test questions. The test questions are much more straightforward. This is a bit more complicated. All right, so that's what you're doing. And they drew it kind of that way. Give you a hint that this is probably going to connect. This carbon here is going to probably connect this carbon here. So that's what I kind of drew like that. It's a hint. All right, you got another one on that group?
Yeah, nobody else has it.
Sure, what the heck?
Okay, G.
G.
From the same question.
G, okay. Okay, first, that's a primary alcohol, right? And primary alcohols undergo oxidation. You got a strong oxidizing agent like KMNO4. This gets oxidized all the way to a carboxylic acid. Okay, so what do they have? They have, oh, you also learned that you have this. And you add KMNO4 to this. You break this bond. Carbon double bond becomes carboxyl double bond. And you also learned that as long as the carbon that has a double bond to the oxygen has hydrogen, further oxidation is possible. See, so that's why I put this in brackets. It's going to keep right on oxidizing all the way to a carboxylic acid. Actually, two carboxylic acids. Okay, so if you have a primary alcohol, it will oxidize to carboxylic acid. If you have an alkene that has, hydrogen here, it will oxidize to a carboxylic acid. Okay, so what about if you have both of them together? Yeah, well, that's what happens. In the lab, you had this compound in the lab, cyclohexene. Remember that? And you had KMNO4. That was probably last semester. And you made a dipic acid. You snipped this piece. So this carbon double bond becomes a carbon oxygen bond. This carbon double bond becomes a carbon oxygen bond. But the molecule is connected to itself. So you don't get two pieces. See, if it's a cyclic compound, you snip it, you get it unfolded, and you get one molecule. If it's not a cyclic compound, you snip it, you get two pieces. Okay. All right. So your molecule contains both carbon double bond and the alcohol. The molecule in the end. So that's why you're going to get a bunch of carboxylic acids. Where the double bond is located. Okay, so here's the double bond. Okay, so this carbon here becomes a carboxylic acid. And then on top of that, you snip this piece here. Okay, so what a mess. So you see this carbon here. Carbon double bond now becomes a carbon oxygen double bond. And if you have hydrogen still attached, which we don't here, there's no more it becomes a OH. So this further oxidizes to a carboxylic acid. So you're going to get crazy looking compound.
Where did that double bonded O come from? That's what I can't figure out, like the two
Where did-
double bonded O's next to each other.
Where did what now?
The double bonded O on the top, next to the.
Yeah.
Where did that come from?
Probably doesn't belong there. Yeah, it does. Now, actually, see this carbon-carbon double bond. It becomes a carbon oxygen. So this is tagged here. This is tagged here. So I break this, replace this with a carbon oxygen bond. Replace the carbon oxygen bond.
That's what I was confused about. I was like, where did they get that?
And if you don't have any H's here, you're done. Okay, but if you still have an H, you're not done. So the starting material they started with this right here. This has an H. This has an H. But this doesn't. There's no H's attached to this carbon here. So you're going to get a mass. And actually, this is not particularly stable. But that may be the final product they gave you. It may have been this. Sometimes these things decarboxylate. I'm not sure. It was the final product that they gave you.
That's it.
And that's a kind of a bit messy one, but I'll break it two questions. They combine two functional materials. There's a primary alcohol and a carbon-carbon double bond, and both of them react with potassium or manganese. Okay. Other ones from any questions from any?
Anything about boiling points or solubilities?
No. That's definitely sure. At least you know it. You ever take a standardized test, carboxylic acids for their size, so the highest boiling points and the highest solubility in choice. And then what's in the second place is alcohols. They have the second highest boiling points, the second highest solubility in water for their size. Anybody have PCATs coming up or MCATs coming up?
PCAT.
PCATs? Other comments or questions? I don't think it's a particularly difficult test. So it's only 2 chapters. Chapter 21, don't read every little thing. There's just way too much. I would say start with the summary section, because they give you a pretty extensive summary section. And it's, so start on page 1017. When they actually discuss these summaries, they don't just give you a list, it's kind of summarized. So start on page 1017, tells you how to make acid chlorides and how they react, then tells you how to make anhydrides and how they react. So start on 1017 rather, and then when you get to 1028, there's a lot in there. And a lot of these reactions in chapter 21 are just recycled reactions that you've seen. Comments, questions? All right, so Monday at 5. And you'll have, plenty of time, I don't have any in the class, so if you need a bit of extra time, that would be fine. Rush off to some class. All right, good luck, study hard.